this series of videos, we're looking at Renishaw's Productivity Plus Active Editor Pro software. Active Editor Pro is a Windows-based application that's designed for the programming of Renishaw's spindle probes and tool setters. Its primary purpose is for the setting up of parts and tools prior to the manufacturing process, but can also help control that process while it's running. So in the last couple of videos, we've looked at some programming, we've looked at setting up the coordinate systems, the model. What we want to do now is actually really focus on the selection of features we've got for creating on that solid model and what options are available for those. So what we have here in the top is our list of measured statements. We have a point, we have a line, a circle, a plane, 2D corner, 3D corner, and a web or a pocket. So those are what we'll focus on today. We do have two sets of these features. The first set we see here, these are all programmed from the CAD model. There is also a complete copy of these, which you see have this little keyboard icon next to them. These are called basic statements. So these are ones we can use if we don't actually have a CAD model or we want to program separate to that model. So I'll give you an example of those as well in a minute. First off, let's look at our measured point. So with the measured point, and actually I'm just going to zoom that in a little bit. With measured point, we don't need to select any actual geometry. It's just the surfaces of the CAD model that we're looking at. So as we move around, you'll see pretty much all the surfaces that are available will be highlighted as something we can actually program off. So again, I've done it in a previous video. We're going to select that top and we will generate this dialog. All of these features will come up with the same dialog. We've seen it before with some other elements as well, where we have help images on the right hand side and we have some help text to hopefully guide the programmer in what each of the settings is doing. At the top here we have our positions. Now these are grayed out. The reason they're grayed out is because this is programmed from the CAD model. So we can't edit those, it's taken purely from CAD. What you will see is you'll see a position in the top, and that's our target point where we're going to probe. And then we have an approach point. So this will be a vector that's perpendicular to the surface no matter which way you're probing. Now, because it's from the CAD, you'll only see a slight difference, 0.1 millimeters in this case, from the target position. It doesn't really matter how far away that is. The approach distance is determined in the inspection cycle, which we've seen in the previous video. What this is really doing is just showing us the vector that we're going to travel into that surface. So we have that there. We have the ability with these features to include a stock allowance. So this could be that the solid model is a finished component, but actually at this point it hasn't been machined yet, and you've probably got maybe say 10 mil, 20 mil, whatever it is of stock that's on that surface. So you can add that here by using this function. So the probe will try and probe where the actual material is at this particular point in time. Okay, a few other outputs there, but we'll move on to the next feature. Okay, so that's our measured point. So coming on to the next feature then, we have measured line. So much as before, if we move the mouse around the model, it will highlight all of the lines that we can actually potentially program. The slight difference here is that we can actually pick a geometry as well. So you'll notice if I'm picking this line, there's a lower geometry and an upper geometry. Typically, we tend to program the upper. It's far easier because then we can program an inspection depth, which is a negative value down from that top geometry. You could program the bottom one and have a positive value, but just typically in the way that most of us will program, this seems a slightly more logical way to do it. So I can see I've got that surface highlighted. I've got the brighter orange line of that geometry highlighted. So I'm going to double click that. Now that's added in this feature. So as before, we have some information here that's grayed out because that's come from the solid model, which is showing us our start and end points of that geometry. It's showing us that the actual direction is in the positive Y direction, which is the most sort of common linear axis that vector can pick. So we can't edit those, we don't need to change that. First setting we're interested in here is our inspection depth. So this is what I was talking about. This is that top line of geometry down to basically the hemisphere of the ball on the stylus. So we can see that in that image here. That is that distance, and I've got that set to -5. We'll have a look at that toolpath in a minute to see if that works. We could choose our line direction, whether it starts at P1 to P2. We could choose the number of points. So I might want to say, I don't need to probe all 6. I'm going to probe 2. It's a minimum of 2 points on a line. That allows us to get our angle component as well. There are some various other methodologies here that we can change. So I'm actually going to hit OK at this point to close that dialog. And so we can zoom in and see our toolpath here. And actually I can still change some of these elements by altering it here. I've got the line selected, so I can change maybe our inspection depth. I'm going to reduce that to -2. And what we should see here is that toolpath respond. Now that's raised up, so it's now a -2 from the top geometry to the ball radius. We can then change some of these other parameters. We have this linear toolpath type. We can actually change our clearance from the ends, so I might want to increase those. Let's say I'm going to change that to 5mm, change that to 5mm, and we can see that has shortened that toolpath. So any one of these features, there's a series of parameters that allow you to then manipulate how that toolpath sits on that particular feature. Okay, so there's an example of measured line. Just going to come back out. We'll look at circle. So zooming again. As before with a circle, same as the line, you've got the surface we can see selected there. I could choose the bottom or top geometry. It's not just complete circles, it could also be arcs as well. So as you can see as we move around, there are arcs that can get selected. But we'll pick that circle, hit enter, and same situation as before, grayed out information, choose our inspection depth, change our type of measurement strategy, so whether it's a macro 4-point or maybe it could be a 3-point bore that we want to do. We can also do some other things with this. So for example, we might want to add in a retract height. We can see here that toolpath runs inside that bore. If I switch it back to a 4-point macro, that's running right through the center. Now maybe on your part there might be an obstruction in the middle that you want to avoid. So to do that, you can use a retract height. So if I switch retract height to yes, and we'll see this new setting appear which has a distance. This is showing 5mm. I could increase that, and just so it's clear to see, maybe I'll increase it to 50. And now we can see that toolpath raise up quite high there. So there is an option there where you can actually navigate over the center of a particular feature. Moving on, we have our measured plane. Now, a measured plane requires at least 3 points. In this case, actually, it's specifically 3 points. And that's done by 1 click, 2 click, 3 click. That will generate your plane. There are a couple of other options available with a plane. I have this pull down here. I could choose our endpoints rectangular, which basically allows me to choose a rectangle that a certain number of points are going to probe that plane with. Or we also have a radial option as well. So if I choose that, as I navigate to this circle, for example, and select that, hit enter, that's going to put a plane either on the inside or the outside of that circle, depending on what I choose. So a couple of options there for setting up a plane. 2D corner. This could be any 2D corner. You're basically choosing 2 different lines. So for example here, I'm going to choose a line there, choose a line there. That's going to give me these points. So the start point and also the point that's the apex of that corner. So that apex could then actually be used for setting your coordinate system position or something like that. As before, with all of these other features, various of the parameters that allow you to set the inspection height, how short or long the measurements are on those 2 sides. Moving on, we have a 3D corner option. So for this, I'm going to use a different coordinate system. Now, I've set up a multi-axis coordinate system so I can access a particular feature on this model to demonstrate these features. I'll be looking at multi-axis in a future video and how you can set that up. So we'll tackle that later on. But for now, I'm just going to set that coordinate system. I'm going to hit on my isometric view, and I'm going to change this to align it to the default coordinate system. There we go. Okay, so now I'm going to zoom in. So to look at the 3D corner, I'm going to select 3D corner, and as you can see here, I can pick the 3 faces of that corner, and that's now going to generate this toolpath. It's created a new inspection cycle because it's in a different coordinate system. It's a rotated coordinate system, and again, we'll tackle that more in a future video. This is probably the quickest one you could do to set a coordinate system. Instead of having to maybe probe a point and then a bore to get your X, Y, and Z, this one feature hits X, Y, and Z in one go. So if you have a 3D corner such as that you can probe off from your part, it's the quickest way to actually get those 3 axes and update a coordinate system. And then finally we have Web Pocket. So this is basically an internal or external groove, but it can be a rectangle. We have the option to include the ends on that. So if I choose this, and we'll use this part for programming, what you'll see is I can pick that surface and that geometry. What it's going to do now, it's going to want to see the other side of that feature. So I'm just going to rotate it around. And as I pick that, you'll see this blue rectangle appear over the top. So we know we've now constrained our web in this case. So I'm going to click that. So that's fine. I could hit enter now, and that gives us our ability to measure this width. If I keep programming, I can actually bring on the 2 ends, because in this case we have some ends we could measure as well. And I can do that by, again, just highlighting on the model, selecting there, spinning it round to the other side, and then selecting that opposing face. Now that's completed this Web Pocket measure, so we've now got a full rectangle measure. I'm just going to hit OK on that. So we can see that toolpath there, and we can see these points measuring at the end. You can switch that off, so I can choose measure ends to no, and you're just going to measure those 2 width sides there. So that's completely up to you, but of course we've programmed it, so that's now available. Okay, so that's all of the features we have that you can probe directly from that CAD model. One of the things I did want to show very quickly is the basic statements. They're all exactly the same, they're all programmed exactly the same way, but there is a subtle difference. So just going to jump into G54 and we'll look at this circle measure here. So with this circle measure, because it's programmed from the CAD model, it's associated with that model. And what that means is if I move the model, then that actual programmed feature will move with it. So just as an example, I'm going to go into our solid model tools. I'm going to select all of the bodies we've got here, and we're just going to move them up in Y 50 millimeters. So if I hit apply, what we'll see is that part is now shifted 50 millimeters, and actually the features have all moved with it because it's programmed from that CAD model. So if I just undo that. Now, if this was a basic statement where it's not programmed from CAD, so what we can do is actually program one. So I'm going to choose a basic statement. Here is the information that we can type in. We can type in ourselves the position, the size, all of those things, and we hit OK. Okay, so this circle is a basic statement. It's not tied to the model. And what that means is actually if I do that same activity and I move that 50 mil, what we'll see is actually that toolpath now stays with the coordinate system. So we could delete all these solid models out and all the toolpaths would stay. So a basic statement is exactly the same as the measure statement. It has the same functionality. It just means you can manually create those sizes and positions yourself, have them tied to a coordinate system, and you wouldn't need to import a solid model in order to generate a program. Any of your existing probe statements can actually be converted to basic statements by right-clicking on them and clicking Convert to Basic. So that is something that if you didn't want to use the model, you wouldn't have to reprogram, you could just convert them. If you've got a solid model, yes, likelihood is you're going to want to program from that, and it's the association, but this obviously offers full flexibility for those situations where you don't have an exact replica of the part that you actually want to program. Okay, so that's all the measured statements. If this has been of interest to you, please visit www.renishaw.com/productivity+ for more information.